Welcome to Realityv4.0 patch notes. We begin with a phenomenon that defies comprehension, the observer paradox. At its core, the observer paradox suggests that reality remains fluid, undetermined, until an act of measurement forces it into being. This is not speculation. It is a fact borne out by decades of experimentation. Today we will probe this mystery, tracing its roots in quantum physics, exploring its resonance with simulation theory, and considering how mastering it could alter our trajectory. You are not a NPC. Consider a particle, existing not as a fixed entity but as a probability, a superposition of all possible states. This is not a theoretical abstraction but a measurable reality, first articulated by Erwin Schrödinger in 1935, with his now iconic thought experiment. A cat in a box, its survival tied to a quantum event. A radioactive atom that may or may not decay. Until the box is opened, the cat exists in a superposition, alive and dead simultaneously. Observation collapses this ambiguity into a single outcome. This is not a metaphor but a demonstration of quantum superposition, a state where reality hesitates until measured. Why does observation wield such power? Why does the universe require a witness to resolve itself? The implications are inescapable. At the quantum level, reality is not a passive stage. It is a process activated by measurement. To grasp the observer paradox, we turn to the double-slit experiment, first conducted in the early 20th century and refined in countless iterations since. When electrons are fired at a barrier with two slits, their behavior defies classical expectation. Unobserved, electrons exhibit wave-like properties passing through both slits simultaneously to produce an interference pattern, a series of light and dark bands on a screen. This pattern, documented as early as 1927 by Davison and Germer, confirms that quantum entities exist as probabilities, not certainties. But introduce a detector to determine which slit an electron traverses and the outcome shifts. The interference pattern vanishes, replaced by two distinct bands, as if the electron now observed reverts to a particle, choosing a single path. This collapse, observed consistently, occurs instantaneously, regardless of when the measurement is made. What constitutes observation? A conscious mind? A mechanical device? Research published in 2021 suggests that the boundary between observer and system blurs at quantum scales, entangling the two in a feedback loop. This entanglement, this interdependence, underscores a chilling realization. Reality is contingent upon interaction. The observer paradox aligns with the simulation hypothesis, proposed by Nick Bostrom in 2003. If an advanced civilization, wielding vast computational power, could simulate entire universes, if so, we might inhabit such a construct, a reality rendered not in totality but selectively as needed. In computational terms, this selective rendering is known as lazy evaluation, a technique where a system processes only what is immediately relevant. The observer paradox mirrors this. Quantum systems linger in superposition, uncomputed, until observation demands resolution. A 2017 paper posits that such efficiency is a hallmark of a simulated universe, conserving resources by deferring detail until required. This convergence is not mere coincidence. The Wheeler-DeWitt equation, a theoretical framework in quantum cosmology, describes a timeless universe where physical states emerge only through observation. Our reality is simulated. The observer paradox is its mechanism, a subroutine that activates the code of existence. Since observation triggers reality's rendering, then understanding its rules could allow us to manipulate the simulation's output. Quantum systems, once unpredictable, might yield to controlled observation, unlocking new domains. The observer paradox is no abstract riddle. Deciphering its mechanics could grant us unprecedented agency. Consider quantum computing. Today's systems exploit superposition and entanglement, but their fragility stems from uncontrolled collapse. Mastery of observation could stabilize these states, ushering in machines of unimaginable power. Beyond technology, the stakes are existential. Since reality is a simulation and observation its trigger, then consciousness may be integral to its structure. John Wheeler's participatory anthropic principle suggests that observers are not incidental but essential, co-creators of the cosmos. A 2023 study in quantum reports explores how quantum measurement might link consciousness to physical outcomes. To understand the observer paradox is to confront a universe that responds to our presence, a reality that exists only because we perceive it. By probing its depths, we might not only unveil the nature of Realityv 4.0, but bend it to our will, redefining what it means to exist within or beyond the simulation.